this video, we are going to be looking at probability basics and going through a lot of the vocabulary and then some different situations and types of probabilities and a few applications. So this is the probability basic notes packet. It's a 9-page packet. I think the first 6 pages pertain to your notes, and I'm going to do a few questions here and there. I'm not going to do the entire packet because that would take too long, but I'm going to touch upon a lot of things just to give you a good overview of what's going on with probability. So remember, the first branch of statistics is descriptive statistics, and then the second branch is called inferential statistics. Probability is the foundation of the second branch of statistics. Okay, probability is the likelihood that a specific event will occur. Anytime you do a probability experiment, that's an action, a trial, through which specific results, counts, measurements, or responses are obtained. An outcome is the result of a single trial in a probability experiment. So if you think of rolling a die, one roll of the die would be your outcome, and we're going to talk about that in a minute. The sample space is the set of all possible outcomes of the probability experiment, and we're going to look at sample spaces in a minute. And then an event is a subset of the sample space. It may consist of one or more outcomes. Okay, so for example, if you think of a standard die, six-sided standard die, the sample space would be the numbers 1, 2, 3, 4, 5, 6. An event could be rolling an even number, so 2, 4, or 6, and then an outcome could be rolling a 2. Okay, so that would just be one outcome. All right, so for example 1, a probability experiment consists of tossing a coin and then rolling a 6-sided die. Draw a tree diagram to determine the sample space and then determine the number of outcomes. Okay, so I'm going to do this as event 1 and event 2. Okay, so the first event is the coin toss. The second event is a roll of the 6-sided standard die. Okay, so we're going to let H equal a head and T equal a tail. That way I know what I'm looking at here. All right, so when you do a tree diagram, you could have a head or you could have a tail. Then for the head, you could have a 1, a 2, a 3, a 4, a 5, or a 6. That could happen when you roll the die. And then for the tail, the same thing. So you could flip the coin and get a tail. And then you could get a 1 on the die, a 2, 3, 4, 5, or 6. Okay, so then that will give you a sample space of these 6 outcomes. Okay, so I'm going to write this. That was a lousy bracket. Let's try again. Okay, each one. So flipping a head and getting a 1 on the die, a head and then a 2, head then a 3, head then a 4, head then a 5, head then a 6. And then we can go to the tail. So tail then rolling a 1, tail then rolling a 2, tail then rolling a 3, tail then rolling a 4, tail then rolling a 5, and then tail then rolling a 6. That's a much better bracket. Okay, and then that means there are 12 total outcomes. Okay, so that gives you 12 possibilities. Okay, the next thing I'd like to do is we're going to flip over to page 3. Okay, and what I'd like to do is look at a practice question. So this is the top of page 3. Okay, example 3. Determine the number of outcomes in each event, then decide whether each event is simple or not. Explain your reasoning. So a simple event, and this goes back to page 2. So a simple event is an event that consists of a single outcome. Events are typically represented by uppercase letters such as A, B, and C. So in example 1, the event of tossing heads and rolling a 3 is a simple event and can be represented as A equals H3. The event tossing heads and rolling an even number is not simple because it consists of 3 possible outcomes that can be represented as B. So a simple event has just one outcome. If it's not simple, that means there'd be more than one outcome that could be represented. So this is saying if event B or B would be head in a 2, head in a 4, head in a 6. So we want to decide, are you just getting a simple event or not? Okay, so sorry if that wasn't so clear. All right, for letter A, for quality control, you randomly select a machine part from a batch that has been manufactured that day. Event A is selecting a specific defective machine part. So you're just getting one particular part that's defective. So that is one outcome. So it's simple. So the event is simple. Letter B, you roll a 6-sided die. Oops, that's a typo. Event B is rolling at least a 4. Well, if you roll at least a 4, you could have a 4, a 5, or a 6. So there are 3 outcomes. So it is not simple. Event C, you ask for a person's age at his or her last birthday. Event C, the student's age is between 18 and 23 inclusive. So that would be 18 years old, 19, 20, 21, 22, and 23. So this is not simple. You have multiple ages that fall into that event. However, event G, the student's age is 20. 20 is the only possible outcome, so this would be simple. Okay, so hopefully that clarifies what a simple event is and what's a not simple event. So if it's simple, there's only one outcome. If it's not simple, there are multiple outcomes. All right, moving along, we're going to look at the types of probability. So there are 3 types of probability. Subjective probability, and I'm not going to read this all to you, but that's just saying what's the probability that there's a pandemic in 2020? So if you had asked that in 2019, especially in the first half of 2019, people would have said 0%, right? So that's just kind of making a general guess, but it wasn't actually using actual data. Classical probability is what it should be. So if I give you a spinner and it's got something like this, so let's say the spinner is divided into 8 sections. This is red, this is blue, yellow, blue, yellow, blue, yellow, blue. And I said, what's the probability of getting a red? So the probability of getting a red would be 1 out of the 8 sections. I'm going to highlight it as pink. Okay, but that would just be 1 out of 8. So it's what you're supposed to get. Empirical probability is, okay, let's say I spin a spinner 10 times and I record that data, and then I look at that data to determine what was the probability of actually getting the red. So the experimental is actually looking at what actually happens. All right, and for our rounding rule, we're going to find the exact answer as a fraction. And so we're always going to get the exact answer as a fraction, and then we're going to round to 3 decimal places. Okay, so I'm going to go on to page 4. This is page 4. Okay, and we're going to start looking at some classical probability questions. So this is used when each outcome in a sample space is equally likely to occur. Classical probability for an event E is given by the probability of E equals the number of outcomes in event E divided by the total number of outcomes in the sample space. I feel like that's pretty complicated when these questions really aren't that difficult. So don't let that intimidate you. All right, you roll a 6-sided die, find the probabilities of each event. Event A is rolling a 3. Well, our sample space is going to be all the possibilities. You could have a 1, 2, 3, 4, 5, 6 in a standard 6-sided die. The probability of rolling a 3 is going to be one outcome out of the 6. So this is the exact answer. And then if you're going to find the rounded answer, you do 1 divided by 6. And now I want 3 decimal places. So I have 0.1666. So the next number was a 6. So that's going to round this up to a 7. So by 3 decimal places, it'd be 0.167. So this is the exact answer as a fraction. This is the rounded. Okay, event B, what's the probability of rolling a 7? Well, there are no 7s in our outcome, so this is 0 out of 6, which is just 0. It's not likely. It's not going to happen. All right, event C, rolling a number less than 5. Less than 5, so it does not include the 5. So that would include the 1, 2, 3, and 4. So there are 4 ways that that can happen out of the 6. This is an exact answer. If you wanted to reduce it to 2 out of 3, that is an exact answer. And then if you did either one of those in the calculator, you're going to get the same decimal. It's going to be 0.6 repeating, so 0.6666. And remember, go to the next digit. That's a 6, so that's going to bump it up, so 0.667. So we always give 3 decimal places when we are rounding. Event D, rolling an odd number. So what's the probability of rolling an odd number? Out of these 6 outcomes, 1, 3, and 5 are all odd numbers. So there are 3 ways that can happen out of 6. If you wanted to reduce that to 1/2, that's perfectly fine. Both of these are the exact answer. And if you divide, hopefully we all know you would get 0.5 as your answer. Okay, great. So now I'm going to keep going through our packet. The card question, maybe that's something that we'll talk about at a Google Meet. And then I do want to go over the last type of probability, the experimental probability. It could also be called statistical or experimental. Empirical, all 3 of those are synonymous. So it's based on observations obtained from let me try again, is based on observations obtained from probability experiments. The empirical probability of an event is the relative frequency of event E. So you have your frequency divided by your total. So I'd like to go down and look at number 8, just because this one's a little bit harder than the other one. So I just thought that this would be a good one to choose. So for number 8, I'm on page 5. Page 5, number 8. A company is conducting a phone survey of randomly selected individuals to determine the ages of social networking site users. So far, 975 social networking site users have been surveyed. The frequency distribution below shows the results. So here's our distribution. This means total. So there are 975 total individuals who have responded to the survey. And then this is telling you how many are in a particular age category. So 156 individuals were between and inclusive ages 18 to 22. 312 were between and including ages 23 to 35, and so on and so forth. So the question A says, what is the probability that the next user surveyed is 23 to 35 years old? Well, if I look at that, I would be going to this particular part of my chart. Okay, and there are 312 individuals out of the 975. So this is my exact probability, my exact experimental probability. And then again, we can round that to 312 divided by 975, and then you're going to get 0.32. Okay, so this one does not go on forever. It's terminating instead of non-terminating. All right, and then letter B, what is the probability that the next user surveyed is 36 to 49 years old? So the 36 to 49, I'm going to highlight in yellow. Okay, and now you're looking at 254 individuals out of the 975. That's your exact answer. And then we can do 254 divided by 975. And this time I get 0.260513. So if I look here, 1, 2, 3 digits, the next digit after the 0 is a 5. So this is going to round this up, and I'm going to get 0.261. Okay, I am going to do a letter C, just so you could see one that's a little bit harder. What is the probability that the next user surveyed is? And I'm going to say 23 to 49 years old. So now I'm looking at both the pink and the yellow. So I just expanded it to 2 rows. And then all you would do is the 312 plus 254, and I would get 566 out of the 975. Okay, so I did kind of do an extra piece for that one, but then, and then we have to be careful with our rounding for this one. So I get 0.5805, so that 5 is going to bump that to a 1. Okay, so that was just a different one that we could see as an example. All right, I'm going to go on to page 6. This is our last page in our notes packet. I'm not going to do the entire last page, but I do want to talk about a few things. So the first thing I want to talk about is the law of large numbers. As an experiment is repeated over and over, the empirical probability of an event approaches the theoretical or actual probability of the event. I love to do this question where I give students a coin to flip 10 times. And everybody records how many heads and how many tails they get after 10 flips. And sometimes a student might have 2 heads or 2 tails or 1 tail. And that's not the theoretical probability. So the theoretical probability is that you should get 5 heads and 5 tails, but that's not what actually happens. But let's say each student did 10 flips, and now I put a class of 20 together. Now I'm looking at 200 flips of the coin. And when I do that, now that probability should be getting a lot closer to the 0.5, because maybe one student had 2 heads. Maybe one student has 2 heads and another student had 1 tail, and they kind of balance each other out. So that's called the law of large numbers. Another thing I just wanted to mention to you is the range of possibilities rule, and it talks about likelihood. So every probability has to be between 0 and 1. So 0 is impossible and 1 is certain. So it's May 14th. What's the likelihood that it's going to snow today? It's pretty unlikely. We did get a little snow in May this year, but it's 2020, so clearly anything can happen. But in general, it's very unlikely that you're going to have snow, okay? What's the probability that it's over 70 degrees in Connecticut on a day in August? That's very likely. Very, very likely. So that would be closer to 0.9, 0.95, but all of your probabilities are between 0 and 1. All right, let's finish up with a couple probability applications. So question 10, a probability experiment consists of tossing a coin and spinning the spinner shown below. The spinner is equally likely to land on each number. Draw a tree diagram to determine the sample space and the total number of possible outcomes. And then we're going to look at a couple of probabilities here. So our first event was the coin toss. So event 1 was the coin. And event 2 is the spinner. Okay, and the spinner is going by the number. So the spinner is going by the number. So we have a head and you have a tail, okay, and you have 8 possibilities for each. 4, 5, 6, 7, 8. Clearly, I'm not going to have enough room here. This is an issue I had with a video yesterday that I did for a different class. Totally ran out of room. I was trying to minimize pages for you guys. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So let's write out our sample space because I think the sample space will help us enough. All right, sample space. Okay, so here's my bracket. H1, a head, then a 1 in the spin. Head, then a 2, head, then a 3, head, then a 4, head, then a 5, head, then a 6, head, then a 7, and then head, then an 8. And then I would do the same thing for tail. So tail 1, tail 2, tail 3, tail 4, tail 5, tail 6, tail 7, and tail 8. So there are 16 possible outcomes. Now we could have looked at the spinner by color as well, but right now we're just doing the number. So find the probability of tossing a tail and spinning an odd number. So you want to look at how many times does that happen. So the tail and an odd number, I'm going to do this, I'm going to underline them yellow. So a tail and an odd number would be T1, T3, T5, and T7. So there are 4 ways that that can happen out of the 16. That's your exact answer. If you reduce, you get 1/4. And then if you divide that, you get 0.25. Okay, the next one, find the probability of tossing a head and spinning a number greater than 3. So greater than 3 would be each 4, 5, each 6, each 7, each 8. So now there are 5 ways that that could happen out of the 16. Okay, so I'm going to do, and that was in pink. Okay, so now I want to do 5 out of 16. So 5 divided by 16, and I'm getting 0.3125. So this next number is a 5, so that's going to round it up. So I'm going to do 0.313. So 5 over 16 is my exact answer, and my rounded answer is 0.313. A lot of these probability concepts you probably have seen before. That is my subjective assumption. So that is not based on theory or experiments. That's just my gut feeling. But I do believe that a lot of this should be familiar. And we will spend this next week on this math. And thank you for watching, and I hope you have a great day.